Okay, I'd like to look at another important topic for this class. This is exponential functions. An exponential function can be written in the form y equals ab to the x power, where the input is the values of x, which is an exponent. And again, we could write this as f of x is equal to ab to the x power. Okay. Now, in this example, I'm going to graph this function here, but usually in a simple exponential form, it's y equals ab to the x power. And in this example, we're going to let a equals 1 and b equals 2. So if a equals 1, 1 times anything is the same thing back. Okay, so we're going to graph y equals 2 to the x power, or f of x is equal to 2 to the x power. So remember, this time our inputs are going to be x, and our output is y, which is f of x. Okay, I made a table here, and we're gonna plug in these values here. I'm gonna start with the bottom one here, with the x being 3. Remember, the 3 is going to be the exponent. Okay, so we're gonna say so y, or f of x, is 2 to the third power, which is 2 times 2 times 2, which is 2 times 2 is 4. 4 times 2 is 8. Okay, so when the exponent in this function here is 3, then my output is 8. Okay, so let's do the next one here. I'm going to erase this to give myself some room here. Okay, so the next one, f of 2, is equal to 2, which is this, to the 2 power, which is this. Okay, so f of 2 is equal to 2 times 2. So f of 2 is 4. So that's 4 here. Okay, and then the next one is going to be 1. So the exponent is 1. So f of 1 is equal to 2 to the first. Okay, so f of 1, 2 to the first. Okay, anything to the first power is itself. Okay, so we have a 2 here. Okay, so this is 2. Okay, so one thing I want you to notice is what's happening here. You have 8, and then half of 8 is 4, and then half of 4 is 2. So it's going down by half. All right. So on the next one, okay, f of 0. If we have f of 0, and we have 2 to the 0 power, so we have f of 0. Okay, so when you have the 0 power, remember, anything to the 0 power is 1, except 0 to the 0 power, which is undefined. So 2 to the 0 power, okay, this is actually equal to 1. Okay, so this is 1 right here. Okay, it sort of follows what's happening here. Okay, we have 2, half of 2 is 1. Okay, but in this case, everything to the 0 power is going to be 1, except for 0. Okay, so then the next one, if we have f of negative 1, remember we have a negative exponent, 2 to the negative 1. Okay, negative exponents, okay, they want to be positive exponents. So this is actually equal to 1 over 2 to the first. And anything to the first power, like this example, is itself. So this is 1 over 2. Okay, so this is a half. Okay, so if this is a half, and then a half of a half, so we know this has to be a fourth. Okay, so which is, if I erase this, we have f of negative 2 to 2 to the negative 2. So f of negative 2 is equal to, this becomes positive 1 over 2 squared. 2 squared, which is 1 over 4. Okay, which is what I said earlier, 1/4. All right, so let's graph these points here. Okay, so I have an x and y axis here, and we're going to graph our points. And remember, the first one was 3, 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So 3, 8 is here. Our next point is 2, 4 over 2 up 4. 1, 2, 3, 4. And then our next point is 1, 2 over 1 up 2. Then our next point is 0, 1. And our next point is negative 1 and then up a half. And our next point is negative 2 and then a quarter. Okay, so you can see what's happening here is if I connect these points, okay, this is an exponential growth function. Okay, and this goes down this way. Okay, now an important concept to remember is that this is getting, we're going to half, a half, a half. We're always going to end up with a fraction. So we're getting closer and closer to 0 here on the x-axis. But we're never going to get there because this is my graph. I'm always going to end up with a fraction here. Okay, if I put a 10 here, negative 10, I'm going to have 2 to the negative 10, which is 1 over 2 to the 10th power, which is a really small fraction. Okay, so in math, the x-axis in this problem is called an asymptote. Okay, hopefully I spelled that right. Okay, that means it gets closer and closer to this value, but it actually never reaches that value. All right. Okay, so this is graphed. Okay, so one interesting concept in math is that exponential functions and log functions are inverse functions of each other. Okay, which means that if I rewrite this, if I switch the values and then solve, okay, so this becomes the log function. Okay, the inverse function of this is a log function. So this is f of negative 1x is equal to log base b of x. Okay, so log base b of x, this is going to be equal to log 2 of x. Okay, so the base, this base right here, the 2 is going to be the 2 that's right here. Okay, it's a subscript. Okay, so remember on inverse functions, what happens is we switch the x and y. So basically, to graph a log function, if I have the values for the exponential function, which is my table, right? Let me get this right there. Okay, if I get those values and I basically just switch them, that's going to be my log function of log base 2 of x. Okay, so let's do that. Okay, so my values for my log function are going to be, let's just switch them here. So this is 1/4, and this is negative 2, and then this is 1/2, and this is negative 1, and then this is 1, 0, 2, 1, 4, 2, and 8, 3. Okay, so basically what I did was I got the same values that I had in my exponential function here, and I just switched them. And that will be these are the values of my log function of log base 2 of x. Okay, if you want to check it just to make sure that it comes out, one thing you could do is you could in your calculator you could put in press the log button and then put log a in parentheses divided by log 2. Okay, and basically this is called a change of base formula. Okay, and the way you can remember it is this is log 2a. Okay, you can make a fraction out of this. Okay, I'm gonna make a fraction. Okay, log a over 2. Okay, log base 2, and this is the subscript. Okay, so if you divide this out here, you're going to end up with the value 3. Okay, because remember 2 to the 3rd power that we did earlier is equal to 8. Okay, so remember the log-based function and the exponential functions are related to each other. Okay, and this is, okay, so 2 to the third is equal to 8, and in the same way, log 2 of 8 is equal to 3. Okay? All right, these two are interchangeable. They're related to each other. So anyways, if we graph this, let's see what this looks like. Okay, so let's graph these points here. I'm gonna put this in a different color. Okay, so we're gonna go 1/4, and remember this is x now. 1/4, we go up a quarter and then down 2. Okay, so it's gonna be like right here, and then the next one is over a half, and then down -1, and then the next one is 1, 0. This is a half. Here I should, and then a quarter, and then a half, and then 1, 0 is here, and then 2, 0, or 2, 1, 2 up 1 is here, and then 4, 2, 4 up 2 is here, and then 8, 3. So 4, 5, 6, 7, 8, 8, 3 is here. Okay, so what this sort of looks like, if you connect the dots, this looks like that. And basically these are mirror images of each other. If I could flop this over on this side, you will get the points. Okay, because remember, basically I just switched the points over. All right, and another thing that this creates, it creates a line that separates the two. We could say that this is y equals x here. Okay, and let's just put a dotted line between there. All right. All right, so an exponential function, this is the graph of an exponential function here. This is the graph of an exponential function, and the inverse function is a log function. So the log function is going to look like this. Okay, so one thing that we can kind of determine here is the domain and range of an exponential function and a log function. So let's look at that. Let's look at the domain and range of exponential function. Okay, so the domain, remember, are the possible values of x. Okay, so along the x-axis, remember if we have an x here, we're going to find a y, and if we go along if we move all the way over here, we're going to have a y. Okay, so the domain of an exponential is basically all real numbers. Okay, so we're going to do negative infinity to positive infinity, and then the range, okay, are the possible y values. Okay, so remember, it's from the y's are going from here up this way. Okay, so it's never going to touch 0. Okay, so this is going to be 0 with the parentheses, and then it's going to go up here to positive infinity. Okay, and remember, for positive infinity, we always use, or for infinities, we always use parentheses. Okay, so this is the domain and range of a log function. Okay, so for the exponential function, remember, in the last lesson, we learned that the inverse function is the domain and range of an inverse function are basically switched. Okay, so the domain here is the range from my exponential function, which was 0 to positive infinity. And when you think about it, okay, see here, this is the x values here. It's never going to touch 0 here, so that's why we have 0, and we're going to go this way. Okay, so the range for my exponential function is all real numbers. Okay, and it makes sense because the values of y, we could have a y value. Okay, it's going to have a y value all the way through it. Okay, so if I have a point right here, I'm going to have a y value going this way. Okay, so there's always going to be a y value. Okay, so this is my domain and range of a log function, and remember the opposite. If we just switch them, we'll find that of an exponential function. Okay, so another thing I want you to see is that in a log function, you can't, the values of x cannot be negative. Okay, so that's a domain error. You can't have a value on this side over here. Okay, so you can't take the log of a of a negative value. You'll get an error, just like if we divide by 0. All right, so this is an important concept that hopefully uh, that you'll understand. This is the relationship between exponential functions and log functions, and we graph them to see what it sort of looks like. Okay, and this is the graph of y equals, or f of x equals 2 to the x power, which is where is that? Oh, we erased it. Okay, so this is the original problem was let me see if I can get that on here. F of x is equal to 2 to the x power. Okay, that's the original problem, which is right there. Alrighty then, we'll look at log properties and log problems in the next couple of lessons.